Last, I want to talk about continuous compounding. So we saw in the previous video that the more you compound, the higher your effective rates are going to be and the higher your future values would be. Let's create a chart of this and then look at what happens if you're compounding constantly or continuously. So we'll have non-annual compounding periods. We'll have a present value, an annual rate, and years. We'll have frequency, periods per year, and future value. Could also do the same thing with the reverse with present value too. So our present value will be 1,000, 10% for 1 year. Frequencies will be annual. Semi-annual, quarterly, monthly, bi-weekly, weekly, daily, and then continuously. All right. So, with respect to this, we'll have 1, 2, 4, 6, 12, 26, 52. Let's see. Sorry about that. I skipped bi-monthly. Let me answer real quick. My apologies. Daily is 365, and we'll do it continuously at the end. So for each of these, we'll now calculate the future value. So it'll be the rate anchored divided by how many times it's compounded per year. N per will be the years anchored multiplied by how often it's compounded. No payment. And then present value is going to be negative B2 for 1,000. We'll end the print and make sure we anchor B2. So now I'll anchor that, send that down. For this last one, for continuously, it's going to be the following equation. So continuously means as we approach infinity. So if we take the limit of that, it's going to approach the number e, which is about 2.72. So in Excel, what that is going to look like is we're actually going to do a different formula. So this will be B2 times 1 plus, and then we're going to do, so we'll do times the exponential function of the annual rate times number of years. And you'll see it's about 1105.17. Another way we could do this effect function is if I copy, let me copy this over with the future value and paste that here. And let's suppose, I had a really large number like 100,000. You say that it's not much difference. Another way you could do this is you could say equal 1,000 multiplied by 1 plus the effect function. Excuse me. Of the annual rate, and then however many times being compounded, so 100,000. So you can see all these results give us basically the same thing, that if it's continuously compounded forever, it's about 1105.17, and it's only a penny more than daily. So now what we can do is I'm going to highlight this data. I'm going to insert, we'll do a recommended chart, see what it comes up with. We can do this particular one, and we'll remove that series 1. So you can see here the compounding increases over time there. So you can look at the different compounding frequencies.